Right. Good morning, students. Look here. Today, our concept, this is third video from ninth class, 8th chapter, motion, types of motions. Today we are looking types of motions. What are they? How many types are there? Look here. Uniform motion, non-uniform motion, and uniform motion, non-uniform motion. Look here. Uniform motion. What is definition? Uniform motion when a body travels equal distance. Remember, equal distance in equal interval. Distance should be equal and time interval should be equal. When distance is equal to time interval, then that body's motion is uniform motion. Look here. For example, 0 kilometers, 100 kilometers, 200, 300. When one vehicle starts its journey, when it is traveling from 0 kilometers to 100, 200, 300, look here, 9 am, 10 am, 11 am, 12 am. For every hour, 100 kilometers it is going. So here, 0 to x-axis, 0 to y-axis, distance in y-axis, time on x-axis. So what is the motion? Look here, it is going equal distance, equal time. This is 0, this is 9, this is 10, this is 11, like that, equally going, equally it is moving. 0 near 9, like 9, 10, 11, 12. Equally it is moving. This kind of motion is called uniform motion. Second, non-uniform motion. Look here, when a body travels unequal distance in equal interval. Time interval is equal, but distance is not equal. Then we will call it non-uniform motion. Same when a body traveling from 0 kilometers to 70 kilometers and 70 kilometers to 130 kilometers, like that it is a traveling. Distance is a difference are there per hour wise. This is called a non-uniform motion. So here you can get any one kind of line, maybe curved line, maybe zigzag line, maybe up to curved line, down to curved line, however way you will get one line. But you can't get a 45-degree line. Where you got in uniform motion, that kind of line you will not get here. Symbols are there. Look here, symbols. Distance symbol, yes. Small s. Displacement symbol, delta small s. Remember. And initial velocity or initial speed. Small difference there, I will explain you. Initial velocity, u. Final velocity or final speed, v. Here speed is equals to velocity. Small minor differences are there. I will explain you when it will come. So I written small differences are there, but both words are nearly 99% same. Look here, speed is equal to distance by time. That speed is equal to distance by time can show v, velocity. I told you already, speed is equal to velocity v. And v is equal to distance by time. Speed is equal to distance by time and velocity v also is equals to distance by time. Acceleration, a time t. Now, what is acceleration? We will look here very clearly. How many types of accelerations are there? What is acceleration? Now we will look. So, what is acceleration? Acceleration, very clear definition I written for you. The rate of change of, look at the rate of change of velocity. The rate of change of velocity, I mean delta s. Change of velocity, delta v term. Change of velocity of an object. The rate of change of velocity of object with respect to time. With respect to time, velocity should change with respect to time. That is called acceleration. How it is? Look here. Acceleration characters I am telling you. Acceleration is a vector quantity, not scalar quantity. Acceleration compulsory having magnitude and direction. Acceleration compulsory having magnitude and direction. That's why we will ask for someone which side acceleration is there. Yes, one ball containing acceleration, but which side? From up to down side, or from down to up side, or from right side or left side, any side will be there. So it is called vector quantity. And initial velocity in acceleration is u, final velocity in acceleration is v. Time is small t, and here it may be, I mean acceleration may be positive, second point negative, third point zero also sometimes. Acceleration may be positive, acceleration may be negative, acceleration may be zero. For example, one stone coming from up to down, then acceleration rate will too much increase. So that is called positive. While coming from up to down, the stone coming from up to down, then its speed is increasing. So its acceleration, stone's acceleration is positive. When down to up going, then stone's acceleration is negative. Zero also be there. Where initial velocity and final velocity are equal, then we will call zero acceleration. Look here, I will explain you after this. SI unit is meter per second square. Why meter per second square? Acceleration A is equal to v minus u by t. So here v meter per second, u also be meter per second. Look here. V, velocity v is equal to distance by time. So distance by time is equal to meter per second. And here another time there t. Have you seen? V purpose meter per second. Then this t purpose. So meter per second time t purpose. So totally meter per second square. Right, look here my dear students. Now we are speaking positive acceleration, negative acceleration, zero acceleration. What is positive acceleration? What is the differences? Acceleration is divided into three types. Positive acceleration. What is positive acceleration? Look here. When initial velocity is lower, remember, lower than final velocity. When initial velocity u is lower than the final velocity v. So here, now how we can understand that acceleration formula? A is equals to v minus u by t. Then what is u? Generally I taken u is equal to 20 meter per second, v is equal to 50 meter per second, t is equal to 5 seconds. Generally I taken. So here v 50 minus 20 by 5, 30 by 5. So 5 ones are 5, 6 are 30. 6 meter per second square. 6 meter per second square. Initial velocity lower than final velocity. Initial u 20, final v 50. So it is lower than. That's why we are calling it positive acceleration. That's why we are calling it positive acceleration. Second one, negative acceleration. What is negative acceleration? Look here. Negative acceleration, simple. When initial velocity is higher than, very clear, initial velocity is higher than final velocity. So here, initial velocity higher than final velocity. Initial velocity is 100. Final velocity is 60. Look here, formula wise, A is equals to B minus U by T. 60 minus 100 by 4. So here, minus 40 by 4 is equal to minus 10 meter per second square. So it is called negative acceleration. Next, zero acceleration. What is zero acceleration? Initial velocity is equal to final velocity. Look here. When initial velocity is equal to final velocity. So here initial velocity is 50, final velocity is 50 meter per second. Formula wise, A is equal to B minus U by T. 50 minus 50 by 10. Time t 10 seconds I taken. So 0 by 10, 0 meter per second square. So it is called zero acceleration. And here graphical representation of motion. We have seen uniform motion, non-uniform motion. Graphical representation, how we can show graph wise. So graphical representation of motion. Look here. First one, distance time graph. Distance time graph. Second one, velocity time graph. Second one is velocity time graph. Look here, velocity time graph, distance time graph. Uniform velocity. I take it. Uniform velocity. Look here. This is for distance purpose, y-axis, and on x-axis we are taken time. And here there is 0 point. This is velocity line. B. Velocity line is going 45 degree. 45 degree. Equal distance, equal time interval. Equal distance, equal time intervals. So distance S1, S2, time T1, T2. When we are looking here, time in seconds, distance in meters, then uniform velocity or uniform speed V is equals to S2 minus S1 by T2 minus T1. S2 minus S1 by T2 minus T1. And here non-uniform speed. Look here, non-uniform speed. When we are looking non-uniform speed, compulsory velocity line not come in 45 degree line. Look here, like this not came, but it is came in curved form or zigzag form. However it will come. However, velocity line come, but in not come in 45 degree line, because that is non-uniform velocity, non-uniform speed. This is the same, y-axis for distance and x-axis for time. Line is coming curved path. That is called non-uniform graph for velocity. Next, we are looking right. So students, look here. Very clearly, 2 points are there to speak out. Equations of motion. When we are looking in equations of motion, there are three equations. There are three equations for motion. First one, velocity time relation equation. Velocity time relation equation. First equation is that. And second one, position time relation equation. Third one, position velocity relation equation. First equation is V is equals to U plus AT. V for final velocity, U for initial velocity, A for acceleration, T for time. Second equation, S is equals to UT plus half AT square. S for distance, speed, whatever. 2AS, third equation, is equals to V square minus U square. Now we are going to target first equation. Look here, equation of velocity time. Velocity time relation equation. That is first equation of motion. First of all, take a graph correctly. And assumptions are very important here. This is y-axis, that is x-axis. On x-axis I taken time t, on y-axis I taken velocity, because this is velocity time relation equation. Velocity on x-axis, sorry, y-axis, time on x-axis. Then slope is our acceleration. Slope a to b is our acceleration. So this a to b, just take for calculation purpose assumed calculations. First of all, take constant line, equal line, and give it. It is a, it is b, this is d, this is c, this is o. O, A, B, D, C. Okay. And equal line take for B also B. So B to equal line is here, put B. Just take B, velocity purpose. So here A, B, D, C, D, okay. Look here very clearly, velocity purpose B. So where is E? E is this. Right. OE is equals to B. Correct. OA, OE, OC, and after AD, AO, AB, and BD, BC, BE. Please keep in your mind. This is final velocity B. Here actually, here we taken for equal line. And look here, when we are taking very clearly one by one, slope of velocity time graph is AB. Slope of velocity time graph is AB. Second point, slope is nothing but rise by run. Rise by run. Rise in running, how much? Rise in running. So, rise AB is acceleration line. Already I told you. AB is acceleration line. Now AB is equals to, look here, AB is equals to BD. Check. AB is equals to BD. Yes or no? This distance only. How much rise? BD raise. Straight. How much rise? D to B raise. Very clear. AB is equal to BD, and by how much run? AD run. Look here. A to D run. Yes. Here to here it is run. Look here. Here to here is equal to D. So here to here BD by DA. Not there AD. Look here. BD by AD. BD is equal to rise up. AD is equal to run. By AB is equals to, look here, BC. Why BC? BD is equal to, look here, BC is equals to, BC is equals to BD plus CD. Right answer. BC is equals to BD plus CD. And BC minus CD, look here, BC minus CD is equal to TB. BC minus CD is equal to TD. Clear? BC minus CD is equal to BD. That only I can here. So here I take an AB is equal to BC minus CD. Where is that? Here. Yes, here actually BD. BD is equal to BC minus CD. BC minus CD I taken. By AD purpose AD. Actually, what is AB point showing us? Acceleration. AB slope showing us acceleration. A. And BC point showing us what? BC. Look there. BC. What is this? Final velocity. Final velocity B. BC showing us. And CD what showing? Look here. CD means CD is parallel to AO. So AO is equal to initial velocity U. Initial velocity U by AD what showing AD. Where is that? A and D both are parallel. velocity v. Look here, sorry. Both are parallel for time. Look here, a to d time. Time showing us time. V minus u by t. So at is equal to v minus. Look here, send this t this side. A into t is equal to v minus u. Then at plus u, just to send this u this side. So keep v that side. When you are putting u another side, then at minus u becomes plus. So plus u is equals to v, or v is equals to u plus at. Our formula is true. Right.